In this video, we're going to be talking about solving literal equations. So literal equations are equations that have multiple variables. And so a literal equation, when you solve it, it doesn't give you a number. It's going to give you an ugly expression usually, and that's okay. So most of the time, these are going to be formulas like maybe for area or perimeter or equations of lines or something of the sort. So there is a purpose in isolating a specific variable. So we solve them in the same way we solve our regular equation. So let's look at 1a. 1a says to solve for x, so that means we want to get x by itself. Well, the minus 7 right now is with the x, and so in order to get that on the other side, we need to add 7. So if we add 7 to both sides, we get x is equal to 8 plus 7 is 15. That's how we solve our quote-unquote regular equations. Over here in 1b, we're going to essentially do the same thing. But notice, this time, there are no numbers, just a bunch of variables, x, b, and a. We want to solve for x. That means the x we want to get by itself. Well, the thing that is with the x right now is a minus b. In order to move minus b, we need to add b to both sides. So then that leaves us with x equals, these are not like terms, so we cannot put them together. It's just going to be a plus b. And that is our final answer. So when solving literal equations, we're going to generally have a couple variables that we are not able to put together. So let's look at example 2a. Example 2a, solving for x, we have 4x. The 4 is being multiplied by the x, so in order to undo that, we're going to divide both sides by 4. This cancels, and I'm left with x equals negative 12 divided by 4 is negative 3. That's how we solve a quote-unquote regular equation. Now let's look over here. We want to solve for k. That means the k is the one that we want to get by itself. Currently, it's being multiplied by negative 3. So to undo that, we're going to divide both sides by negative 3. So this cancels. On the left-hand side, I'm left with my k, which is what I wanted, k by itself. And on the right-hand side, I can't do anything with that, so it's just m divided by negative 3. And that's it. I can't simplify that or do anything else to that equation. So let's look at one that requires more than one step. For 3a, it says solve for x. So we know how to do this. We know how to get x by itself. First, we're going to add 5 to both sides. Because it says minus 5, so I need to do the inverse. So that would leave me with 16 equals 2x. In order to get x by itself, I need to divide both sides by 2. That leaves me with x equals 8. Notice that's the same thing as x equals 8, going this way. So that's how I solve a regular equation. Now let's look at this equation. It says solve for x, so we want to get x by itself. This is the equation y equals mx plus b, which hopefully we recognize. It's okay if you've forgotten what it is. We'll talk about that in a later unit. So right now what I want to do is get that x by itself. So the first thing I need to do is subtract b. The reason I'm subtracting is because it's addition. What I do to one side, got to do to the other. So this is going to cancel out, and then I get y minus b equals mx. So the b is gone, the mx is still there. I can't combine y and b, which is why it's just y minus b. They're not like terms. So the last thing I need to do to get x by itself, in the same way over here, I divided both sides by 2 because we were multiplying. Mx is m times x, so I need to get x by itself. I'm going to divide both sides by m. So I'm left with x equals y minus b over m. And remember, I could just switch the order. X equals y minus b over m. That is this equation solved for x. Let's look at number 4. To get w by itself, the first thing I'm going to do is move this 14 over. Move the 14 over. What I do to one side, do to the other. This gives me 20 minus 14, which is 6, equals to w. The next thing I need to do to get w by itself is divide both sides by 2. The reason I'm dividing is because this is multiplication, and division is the inverse of multiplication. So my solution here is that w is equal to 3. Now let's look at 4b. It wants me to solve for w here. Notice this is P equals 2L plus 2W. That's the formula for the perimeter of a rectangle. If I want to get W by itself, I need to first move over this 2L. So I'm going to subtract 2L from both sides. So that leaves me with P minus 2L. Those are not like terms, so I just leave it like that, equals 2W. Now what I need to do is divide both sides by 2. And I get W is equal to P minus 2L over 2. Not very pretty, but that's it. All right, last little example here. This one requires a few more steps, but that's okay. We got this. On the left-hand side, I'm just solving for x, so I want to first add 7 to both sides. So I got x plus 5 divided by 2 equals 10. Now what I want to do is get rid of that fraction because I can't mess with the plus 5 because it's all divided by 2. I'm going to undo dividing by 2 by multiplying both sides by 2. I'm left with x plus 5 equals 20. And now the last step I need to do to get x by itself is subtract both sides by 5. So x equals 15. Now let's do the same thing over here, except now I just have all variables. I'm going to do these in the same color. The first thing I need to do to get x by itself is add c to both sides. So I'm left with x plus a divided by b equals, d and c are not like terms, so I can't put them together. So I'm just going to write d plus c. Now the next thing I'm going to do is get rid of the b. This is all divided by b, so in order to undo division, I'm going to multiply both sides by b. But I got to make sure I'm multiplying this entire thing by b, so I got to use parentheses. So that cancels, and I'm left with x plus a equals b times d plus c. The last thing that I need to do to get x by itself is move the a. I'm going to move the a by subtracting a on both sides. So x is equal to b times d plus c minus a. Really ugly, but that's all you have to do. You just can't combine any of those because they're all different variables and they're not like terms.